A gas turbine engine is the most sophisticated device known to humankind. It can have up to 40,000 parts inside, and they're moving at tens of thousands of RPM within a hair's breadth of each other. I'm Michael Winter. I'm the chief scientist at RTX. Two things are essential for flight: lift and thrust. One of the key principles is that the faster that air moves, the lower the pressure becomes. And so as an airplane accelerates down the runway, air flowing over it starts to move faster, creating lift with lower pressure, while the air underneath the wing has higher pressure, sucking the airplane into the air. In order to accelerate the aircraft, one needs thrust, and that thrust is provided by the jet engine. There are only a small number of companies that can produce gas turbine engines for aircraft propulsion. I'm proud that I've spent most of my career working at Pratt Whitney, where we make the world's most sophisticated jet engines. A turbine is made up of turbine blades, each one about the size of my hand. The turbine blades are subject to centrifugal force that could be equal to the weight of an entire fighter aircraft. The turbine blade is usually made up of a single crystal of metal, and it's drilled with thousands of little holes, sometimes with laser beams, that let some of that cooling air out so the hot gas can never touch the surface of the metal. Inside the engine, most of the air actually is bypassed from the core of the engine, but a small amount of the air is sucked in and compressed over and over again. As you compress gas, the temperature goes up, just like your bicycle pump. So by the time you get to the back of the compressor, the temperature is hot enough to melt rocks. And then what do? We dump in fuel and we light it on fire. And then we move the air into the turbine, which extracts that energy and turns it into motion and rotation inside the engine. At Pratt Whitney, we make these propulsion systems that power airliners that we all travel on and travel the world safely every day. We also power military platforms. The F-35, for example, can fly at Mach 1.6, stop, and land vertically. Raytheon provides missiles, radars, and radios. And so together at RTX, we provide exquisite solutions for our men and women in uniform. And it helps them stay ahead of any threats in the air, on the ground, or anywhere in our ever-changing world. We provide air traffic management solutions at Collins Aerospace that bring forward precision navigation through multimodal, secure systems that connect the air domains throughout the world. We control the airspace in 2/3 of the planet. By providing for more direct routing, we can save fuel. When combined with our skills and capabilities for network systems and cybersecurity, we advance these technologies and provide more value to our customers. For our science, technology, engineering, and math graduates and professionals, I have a really simple message. Aviation is cool again. We defend freedom, we support the new space economy, and we make propulsion systems that power airliners that we all travel on safely every day. This is what we do as engineers. At RTX, with our three businesses, Collins Aerospace, Pratt & Whitney, and Raytheon, we are in a unique position to make a difference, to bring forth change that has impact.